So today we're going to be talking about frequency distributions. And what frequency distributions basically are tables that display the frequency of various outcomes in a sample. So each entry has a frequency, which is also known as the number of times that that number occurs in an interval in the distribution. So we can see a frequency distribution as a summary of the distribution of values in the sample. So let's say we have this sample here, and let's say, I don't know, it's the number of questions that a student got right out of 60 on a test, right? So you'll notice that there's 5 by 5, so there's 25 values in this sample. Now, the first step is finding out how many intervals you need in your frequency distribution. So it's a good thing we have this handy-dandy little trick. Number of intervals equals the square root of the number of observations. So like I said, there's 25 here, so we would have 5 intervals, right? And then the way you pick the intervals, I sometimes do guess and check, right? From this sample, you can see that the smallest value is 12 and the largest value is 58. So you would probably do it by tens, right? So let's set up those intervals then. This is our interval. This is our frequency, the number of times it pops up, and then we'll have a relative frequency, which I'll talk about later, right? Alright, so here's our frequency distribution for this sample. As you can see, I've got my 5 intervals, 10 to less than 20, 20 to less than 30, 30 to less than 40, 40 to less than 50, and 50 to less than 60. And then I've noted every single time a number in that interval shows up. So we have 3, 8, 4, 5, 5. And then to double check that you have the correct number, because sometimes, you know, your brain skips over one number or something like that, you want to add them all up. So 11, 15, 20, 25. You're good. Now let's talk about relative frequency. So relative frequency is a way to sort of take your number and then convert it into a percent or a decimal, something that's really easy to see how it compares to all the other intervals in the sample, right? So for a relative frequency, that equation is simply relative frequency is equal to frequency divided by number in sample. Right. Our frequency for the interval 10 through less than 20 is 3, and there's 25 numbers in the sample, so it would be 3 divided by 25, 0.12, and then you just do that for the rest of the table, right? So we've calculated all the relative frequencies for this frequency distribution, and what you want to double check is that these add up to 1. So 0.12 plus 0.32 plus 0.16 plus 0.2 plus 0.2 is, in fact, I don't know, is it worth it to zoom in? Just take my word for it that that says 1. Yeah, that's how you know you've done your relative frequency correctly. And now what you can do with your frequency distribution is you can graph it in a histogram if you want. So for your histogram, your x values would be their interval, those would be the bins, and your relative frequency or your frequency will be your y value, and that's how easy frequency distributions are. Ooh, it's the end screen. Click on one of these links to be directed to that playlist. And don't forget to subscribe!